So, continuing our discussion on the other types of interferences, we will discuss about transport influences now. So, basically transport interferences are caused by alterations in the mass flow of the aerosol. That means sample uptake of the sample uptake depending upon the flow rates of the auxiliary gas as well as fuel gas. So, it has to happen through horizontal cross section of the flame also, because once the metal atoms are there in the flame, there is no reason that the atoms will pass through the flame vertically only. They can pass off horizontally also, no, because flame is an open system in atomic absorption. So, they may lose out the free atom concentration. So, the transport influences are basically dependent upon the rate of aspiration and physical characteristics. What are the physical characteristics? That is viscosity, surface tension, vapor pressure and density of the solution, all these things. For example, if the sample is in glycerol, okay. If the sample is dissolved in glycerol, the sample uptake in glycerol will be much lower compared to water, because water is having a higher lower viscosity, and then water is having higher surface tension also. So, if the sample is in methanol, for example, methanol is density of methanol is very less compared to water. So, the sample uptake will be more. So, less force is required to pull the sample. Similarly, vapor pressure, if the sample is sample solvent is having a very low boiling point, that means the aspiration and for other things will be affected. So, increasing salt concentration, density, pressure, all these things will increase. For example, I have written here increase in the salt concentration above 1%. That means the droplets will be bigger in size. This kind of situation occurs whenever we want to analyze seawater, and then human the body solutions, blood sugar, plasma and several other blood plasma, serum, all these biochemical samples will have more than 1% of the solids in their matrix, in their composition. So, in such cases transport influences are more, that means interference will be, absorbance will be lower than the expected. Similarly, organic macromolecules, proteins, sugars, and if such things are there, they increase the viscosity. So, increasing viscosity obviously leads to lower absorbance and higher interference. Organic solvents, normally 90% of organic solvents burn with exothermic effect. Okay. So, organic solvents catch fire very easily, that is our experience also. So, whenever there are organic solvents in our sample, for example, you may extract the sample in benzene, toluene, methyl isobutyl ketone or methanol, isopropyl alcohol you could have dissolved. So many other organic solvents may be there, and whenever the samples containing organic solvents are introduced into the flame, exothermic reaction takes place and production of with the production of carbon monoxide, carbon dioxide. But exothermic reaction also means higher temperature of the flame. So, higher the temperature of the flame, more would be the free atom concentration. So, this, or if I use organic solvents, I can get higher sensitivity So, it is important to remember such things, and quite often the quite often we incorporate organic solvents in the standard method. Whenever we are trying to develop a new method, we incorporate it so that we can determine the sample at a still lower concentration, that is higher sensitivity. Now, I am giving you a list here of solvent and relative sensitivity. Assume that I have dissolved a particular sample in hydrochloric acid, 0.1 molar hydrochloric acid, and the relative sensitivity is 1. Then suppose I dissolve the same thing in 40% methanol. That means I add hydrochloric acid 60% and methanol 40%. Then what happens? The sensitivity, that is absorbance, will be 1.7 times more compared to hydrochloric acid. Similarly, if I use ethanol, it is almost same, 1.7%, because it depends upon the density of the ethanol. Suppose I use acetone, acetone is having a lower boiling, still lower boiling point than ethanol, methanol, etc. So, the it is twice the sensitivity, absorbance value will be twice. Same sample, hydrochloric acid, suppose it is 0.2 absorbance. If I dissolve it in 40% acetone, it will be 0.4 here absorbance, 0.2 to 0.4, double. Suppose I increase the acetone to 80%, then what happens? I have the absorbance 3.5 times. So, you can feel the power of the organic solvents in the atomic absorption. That means 3.5 times lower concentrations can be determined in atomic absorption if I use acetone. Now, sometimes it is possible to use acetone and isobutanol 20-20. Even then the value is almost double, absorbance value would be double. And then ethyl pentyl ketone, methyl isobutyl ketone, ethyl acetate. So, you use ethyl acetate, you get 5 times sensitivity. So, if it is 1 ppm that can be determined minimum in a given sample, then with if I use ethyl acetate, I can determine 0.2 ppm, that is 200 ppb, parts per billion. So, the determination interference, you can call it interference or increase in sensitivity. Whenever it is done deliberately, we call it increase in sensitivity, but if we do not know that acetone is there, I get a higher absorbance. So, I call it interference. So, it can be interpreted either way. Okay. So, then we are discussing another point, that is solute volatilization. So, in solute volatilization, what happens? Interaction of solute particles containing the analyte, that is copper chloride, cobalt nitrate, or whatever it is we want to estimate, with the other concomitants can influence volatilization and cause enhancement or attenuation of the signal. Enhancement means increase in absorbance, attenuation means decrease in the absorbance. They are generally specific to the matrix components, that means the sample components will decide whether there is solute volatilization or not, and the signal depends upon the properties of the compounds that are formed. That is very simple. Instead of atoms, if the free atoms combine to form another product, then the absorbance will definitely depend upon what type of compounds are formed, exothermic, endothermic, and then free atom concentration will be lower, then also the absorbance will be more, will be less. So, they may also be called as chemical interference, because it is basically a formation of chemical compounds in the flame. So, in such things happen more in premix burners, because in premix burner I do not have the control how much I am aspirating the sample. All the sample is aspirated into the flame, because it has got only one fuel box, fuel cylinder, and then sample also is introduced into the same cylinder through a capillary. So, everything will be burning at the top. So, in premix burner, laminar flame volatilization begins as soon as they enter the primary reaction zone. In the primary, the blue flame range. So, the laminar flame volatilization begins as soon as they enter the blue flame range. So, the occurrence of interference depends on the observation height. Again we are coming back to this observation height, which is very important, and the analyte can combine with the anions or ligands or simply from refractory oxides. So, the metal atom can combine with the anions, chloride, bromide, sulphate, etc., phosphate, carbonate, etc., or ligands like EDTA, NTA and other NH molecules, etc. These are called as ligands, or they may simply form refractory oxides, that is vanadium pentoxide, tungsten oxide, chromium oxide, like that. They can form refractory oxides. If the refractory oxides are formed, they do not dissociate. So, the absorbance will be absolutely nil or negligible. So, we may not know whenever we are determining a substance containing aluminum or any other metal which are refractory, chromium, vanadium, tungsten, all these things, they may simply form the oxides, and these oxides do not dissociate. Free atom concentration decreases, absorbance decreases, very simple. So, this is the effect of observation height. Now, earlier I had given you for chromium, magnesium and chromium, magnesium and silver. Now, I am giving you an observation height effect for chloride, nitrate and sulphate. These are all magnesium salts. What we have done in this experiment is we have taken magnesium sulphate and magnesium nitrate and magnesium chloride, but we have increased the observation height whenever the solution contains sulphate. So, we take magnesium sulphate and aspire, I get a response figures like this. Okay. Whereas, if I take magnesium chloride or nitrate, the response is still higher, but the observation height is smaller. See, observation height increases like this. So, here optimum reading is around this range, but for chloride it is almost, the sensitivity is double, but the observation height is also about half of the sulphate observation height, about here. Okay. Maximum chloride corresponds to half of observation height. So, if you suspect there is sulphate in the sample, then what you should do, observation height should be increased. That means, the flame should be raised further. Okay. So, if it contains chloride or nitrate, the flame should be lowered, so that the maximum sensitivity can be obtained or maximum absorbance can be obtained for lower concentration. So, this is the effect of observation height. Now, oxides of group 3 and 4 of the periodic table form 3-dimensional polymer structures. I think we all know about this. Periodic table elements, silicon, it forms 3-dimensional polymer structures, zeolites. I think all of you must have heard of zeolites, and such things structures persist even when we add hydrochloric acid to dissolve the sample. So, spinel types are available like MEO dot Me2O3. These are the combined complexes, metal oxide and metal oxide in 2 valency 3. Here metal oxide is 2, metal valency is 2, oxygen is 2, here it is. So, it is both of them are combined. So, this metal and this metal could be different metals or they may be same metals like iron FeO Fe2O3 or FeO and then Al2O3, something like this. These are called as spinel types. And there are other structures, 3-dimensional polymer structures which are known as ilmenite, perovskites and several other structures. Mainly perovskites are MEO2 type, metal oxide, metal dioxide. Here it is metal oxide, metal ferric oxide, something like this. All these polymeric structures are known to occur, and once they form it is very difficult to dislodge them from the structures. So, the structures are stable, very stable lattices, and the elements that combine to form spinels and ilmenite perovskites are titanium, zirconium, hafnium, molybdenum, etc. Among these, titanium and molybdenum are titanium, zirconium, these are all refractory elements only. So, the signal depression must occur whenever we have a formation of spinels or ilmenites or perovskites. So, when this happens, whenever there is titanium and then zirconium, hafnium, molybdenum, aluminum, etc. Silicon, yes. I have not put all the elements here, but I may ask you questions in the examination. So, sulfates, the signal depression is maximum when sulfate is there, and then that is slightly more than chlorides, and if it is nitrate the signal depression will not be so much. So, some elements form carbides, for example, tungsten carbide, very strong refractory element which is used in metal edges for metal cutting. Tungsten carbide is coated on even on our shaving blades. So, because it cuts very easily and it does not degrade very easily. So, the formation of carbides, titanium carbide, molybdenum carbide, tungsten carbide, so many elements form carbides, and these carbides are also sort of refractory. Boron nitrides are also there, and carbides, nitrides, etc. These decompose very less even at 3000 degrees centigrade. That means, if you have such elements and you are doing it by flame, you are bound to get lower absorbance. So, the formation of carbides also follows this series, that is hexavalent is stronger than pentavalent than tetravalent metal ions. So, the absorbance decrease is maximum in hexavalent metal ions, less in slightly less, it is more than pentavalent, which is more than tetravalent. So, if the metal oxide is more volatile than the metal or the carbide, then signal enhancement occurs. Some elements form, if suppose there is a competition, there is oxide, there is also the carbon. In the flame there is oxygen, there is carbon. So, if the metal oxide is more volatile, the thermodynamically the formation of metal oxide will be favored because it requires less free energy. So, the signal enhancement occurs, but if it is a carbide, decrease in the signal will occur. So, such insights we can get depending upon the properties of the elements, but these elements are the concomitant elements. They could be there along with the sample or they may be independently also. So, if you are determining titanium, zirconium, hafnium, etc., we say try don't try flame, try some other method of analysis, because the sensitivity is low, interference is more. So, now we will talk a little bit about vapor phase interferences. The equilibrium and incomplete conversion of the analyte into spectroscopically active form, that is atoms only, resulting in the attenuation of the signal, that is attenuation means decrease of the signal, may be considered as vapor phase interference. That means what we are saying is the formation of the atoms and compounds. If the equilibrium is disturbed, atom concentration will change, and if the what is the spectroscopically active term? It means the atom formation. If the atom formation decreases, absorbance decreases. If the atom formation increases, absorbance increases. So, these reactions occur in the vapor phase. That means in the flame where you have no control over the chemical reactions, everything is thermodynamically dependent and upon the free energy changes. So, such alterations occur in primary reaction zone basically. So, for example, diatomic and triatomic compounds like sodium hydroxide, barium hydroxide, beryllium oxides, etc., cyanides, oxides, etc., can alter the degree of ionization markedly. Suppose you are taking copper, it may form copper oxide or it may form copper chloride, and the sample can give higher or lower reading depending upon the concentration of the free atoms. So, such elements like sodium, such compounds like sodium hydroxide, barium hydroxide, barium oxide, beryllium oxide, copper oxide, cyanides, etc., can give rise to problems. So, whenever we want to analyze samples, we prefer to say you dissolve it in hydrochloric acid or nitric acid. Do not dissolve it in any other acids, and make sure that the sample is in a reduction mode, cyanides and other complexes are not there, so that the absorbance can be maximum. So, what are the types of reactions that occur? Dissociation processes take place frequently between the chemical species. For example, metal oxide plus CO goes to metal and CO2. Here production of metal atoms occurs, but this CO is there in the flame, metal oxide is there in the coming from the sample. So, even though it is metal chloride, 90% of the time it is copper chloride, cobalt nitrate, etc. The moment you introduce them into the flame, metal oxide forms. So, the reaction of metal oxide with carbon monoxide gives you metal atom. This is a good reaction, that is beneficial for the production of atoms, free atoms. Similarly, metal oxide can react with C2 carbon atoms and then producing metal plus carbon monoxide plus carbon dioxide. And then there are 2 CO. 2 CO molecules can react with oxygen molecule 2 CO2. This will have a broadband interference. Broadband means resonance line overlapping, and there will be increase in the signal, but it is unnatural. Similarly, cyanogen reacts with electron, cyanide minus, again this has got a broadband decrease in the absorbance. CHO can dissociate to give you CH plus and O minus, and this CH plus also reduces the signal. That means, most of the vapor phase interferences occur because of the presence of carbon monoxide, carbon atoms and oxygen, etc., and they react with the metal oxides. Sometimes there is increase in the concentration of the atoms due to the formation of metals, but if there is a formation of molecular species which have got broadband, then there will be increase in the signal, but it is unnatural, it is an interference. So, sometimes this distribution can take place, interference can take place in a spatial form. These interferences are caused by the changes in the flow rate or flow pattern of the sample in the flame. The quantities of combustion products, they can change the mass flow rate and flow pattern also, which in turn are influenced by the size and rate of volatilization of the particles in particulate matter. So, examples include signal enhancement of aluminum, barium, calcium, lithium, strontium, etc. So, what we are saying is the formation of the combustion products into molecular species can change the absorbance. Examples include either signal enhancement of aluminum and other elements, but it can lead to decrease also. So, in general what we want to say is several types of interferences can occur and they do occur in flame atomic absorption due to several factors. Therefore, even in the absence of specificity, still signal enhancement or attenuation can occur. This is the bottom line. We say like a panacea, if you want to determine without knowing the chemistry of the substance, go to atomic absorption, but knowledge of chemistry and the flame, especially the flame chemistry, molecular species helps in proper handling of the signal. That means you can expect interferences from spinel, ilmenite and other structures, zeolite type structures. Vapor phase interferences could be there, spectral interferences could be there. So, just like a detective, whenever a sample comes for analysis, what we want to know is what else it contains, what are the possible other elements that are present in atomic absorption sample, AAS sample, that we ask. Sometimes if they do not know, then we expect these interferences and try to make adjustment. How we make the adjustment, we will see later. So, we will discuss about the background correction of the flame AAS in the next class. Thank you.